Okay, so we're going to be talking about biomolecules. They're also known as that's my A, C, R, O, macromolecules. Macromolecules. Why would they be called macro? What does macro mean? Oh, you're on the right track of thinking about size. Micro, like microscopic, means little. What do you think macro means?
Oh, big.
Big, okay. Big. Macro means big, okay? And so when we're looking at these molecules, macro means big, okay? These are bigger molecules, okay? Then let's say water or carbon dioxide or calcium ions, some ions that are floating around, okay? And so these are relatively bigger, and you probably saw that, like with the lipids. Do you remember counting on the pogo how you had to count the number of carbons and hydrogens on those lipids? There were quite a few, weren't there? Okay, and because of that, they're often referred to as macromolecules. Macromolecules, biomolecules, they mean the same thing. It's like 6 of one, half dozen of another. It doesn't matter what you call it. I usually use biomolecules because that's kind of what I started using, but that doesn't mean it's the right way. Okay? Now, within this, macromolecules, okay, there are 4 categories. There are 4 categories. And so, let's do this. There are, and I just kind of do this to kind of highlight some stuff, and I change colors around just to kind of separate things for myself. But do you need to do this? Not necessarily. Whatever works for you, please do it. If you are just a straight up word person, you just look at words, then do it. If making things bigger, smaller, if doodling helps you, do it, okay? Now there are 4 categories, and as we're talking about these notes, feel free to take that pogo out from the other day because you may find it helpful to start making connections between these assignments that we're doing and what you're learning. So, here we go. What is one of the categories? Think 4 categories. Think about the other day. What's one of the categories that was covered? Okay, so we know there's 4 categories. And I'm going to do this. Oopsie. I'm going to make 4 lines. Here's my 4 categories. Okay, so what's one of the categories? Look at the pogo. I'm not doing all the notes. I could talk and talk and talk, but until you start interacting, it's not going to start connecting. So, and you guys, I don't believe in hand raising, okay? If you want to say it kind of low and then I don't know where it's coming from because you're not sure, this lets you do that, okay? If you feel confident, if you want to shout it out, that's fine. Woo! I'm making a mess. Okay, but I need you guys to start shouting some stuff. What's one of the categories of biomolecules that you guys explored on Wednesday? Lipids. I think I heard a lipid somewhere over there. So yes, lipids is one of them. Okay, so we have lipids. Okay, lipids are, what did they look like when you looked at it? What did they have when you looked at the pictures on the first page? And then when you were answering questions that had you look at the different categories and find certain images that matched up, what stood out about the lipids compared to the other molecules and their structure? What? chain. Okay, I heard chain. And you know what? Sometimes you guys, I do know who's saying what, but I also I want people to feel like it's an open, so I might not acknowledge you directly, but I oftentimes do hear you, okay? But it's made of chains, okay? It's made of chains. Of what element? What were these chains made out of, or what did they call it? Carbon. Remember the carbon backbone? They said the backbone, right? And what else? What was coming off? It wasn't just a carbon backbone. What was it referred to? And so I still see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 people taking notes, which is awesome, but not trying to put it together and connect with your notes from Wednesday. So take a minute, get your folders out, please.
I wasn't here.
Okay, so those that weren't here, we'll get you one, but there are a lot of people that were here that don't have them. So I'm asking questions. I'm trying to get pens from that. I'm trying to show you guys how to use your notes, use your assignments to learn from them. Use your assignments to learn from them. Okay, so if we're using our assignments to learn from them, okay, I want you to look at the first page. It's the figure 1, the model, and then on the right side, you guys have your questions about it. So we know lipids were made of chains that have carbon and what? There was a question, yeah. Okay, who else was in here? Okay, so you're going to have to do this on your own, but I also, you're going to have to use it right now as we go through notes. So you're going to be multitasking. Okay, look at question number 4. You answered this, so I know you know it. At some point you knew it. Okay, what else besides carbon? It's not just called a carbon backbone. What is it called? Hydrocarbon. Why is it called hydrocarbon and not just carbon backbone?
Because it has water.
Perfect, because it has hydrogen. Hydro for hydrogen and carbon for carbon. Okay, and so you have a lot of chains that look like this. Okay, and remember where we don't have a letter, it's assumed to be a carbon. So if you were not here the other day, you might need to get some notes on some organic chemistry. I can help you during advisory. Okay, and so we have the carbon chain with lots of hydrogens coming off of it. Now, that's just the structure. And there's different ways these chains can be made, okay? Now, with this structure, I'm going to ask you guys something. Okay, so this is going to be kind of off to the side. This part right here, things that are on the left are not going to necessarily be notes, but they're going to be things that I'm asking you to get to our notes, okay? So carbon makes how many bonds? How many lines come off of carbon? Do you guys know how many bonds it can make? I'll give you a hint. Carbon can make 4 bonds. Carbon has 4 valence electrons. It wants to make 4 bonds. So here is CalFarts. Here, whoopsie. Here's methane off to the side. Okay? CH4 is what it's called. CalFarts. Stinky. Love to smell like the farm. Methane. Is this a polar or a non-polar molecule? Can you say that one really loud? Non-polar. Awesome. How many of you guys can look at something like that and think that it's non-polar? Because you should be able to at this point. The reason is Does it have an unequal balance? Does it have a more negative and a more positive end?
No.
No, and in fact, if you have hydrogen pulling, the same hydrogen pulling from all the sides, okay, it's kind of like if you take string, okay, and I took string around Brandon here from this side, and you pull from that side, and you pull from that side, and you're the other hydrogen pulling from that side, he's gonna stay in the middle, isn't he? He's not gonna have any pull one way or the other. So this is a non-polar. So carbon and hydrogen, they make non-polar chains, okay? If they're non-polar, these hydrocarbon chains are non-polar. Does that mean that they're hydrophobic or hydrophilic? Okay, is it going to want to be attracted to water? Think about your water. No, it's not. Okay, remember water, polar molecules like other polar molecules. Remember how we were mixing them together? If they didn't mix, it was because it was non-polar. So if you don't know that, go back into your notes. Okay, non-polar chain. That means that, let me turn this to blue. They do not like, here's my little water droplet. I'm a terrible, terrible, terrible artist. Okay. I'm actually going to make it into like a stop sign. Okay. They are hydrophobic. Don't mix with water. If you did not know what hydrophobic is, this is the time to highlight it. That is a word I will use all semester. If you didn't know polar versus non-polar, those are two things that you need. So at this point, what you need to know, okay, going forward, what my expectations are is that you know polar versus non-polar. And again, things to the right, you can write down if you want, but it's just kind of notes to yourself or me asking you side questions. And hydrophilic versus phobic. Okay? So if it's hydrophobic, it won't mix with water. So give me something that is hydrophobic, that doesn't mix with water. What's something that you guys used in your water stations that did not mix with water? Oil, I heard it out there. Okay, so examples of lipids, I should have put EG, that's the abbreviation, include oils, okay, fats, waxes, so these are all foods, right? Kind of like things that organisms consume. We consume something with oil. We usually consume fats. We find out that these lipids give us energy. We'll talk about function in a minute. But they're also found in cell membranes. And we'll come back to this later on. But these are examples of where lipids are found. Okay, examples where found. Okay. So what I am doing here is I am going to keep using red for examples where these items are found, green for their structure. And then the other colors are just things I'm adding in. So far we have structure and where they're found. Cool with that? Structure, you guys are helping me with because you're pulling it off the POGL. So right now we're just kind of summarizing that POGL you did the other day. Okay, so let's go on to our next group, and then we'll come back to the function, or as we put out in the back, the other word for function is the work that it does. Okay, so lipids. What's another category? Another group of molecules from that Model 1 that we had of biomolecules. What's another one? Saccharides, okay? Monosaccharides are an example of what's called a carbohydrate, and this is, you know what? I'm going to put that one way over here. I'm gonna put it in my last because I'm gonna add a few extra notes about carbohydrates. Carbohydrates and lipids are the ones I'm gonna talk to most at this point. And I'll explain why in a few. Now, looking at carbohydrates and lipids, and then the other two, what stands out about the carbohydrates, the monosaccharides, or the disaccharides, or the sucrose? I know that was on the back page. Look at their structure. What kind of is characteristic of their structure? What elements make up carbohydrates? Let's start there. You answered this on question, or this was given to you. What?
Oxygen and hydrogen.
Oxygen and hydrogen. And there's one other one that is that makes it up. Look at number one. It's not listed because we assume when those lines come together, what element is there? Carbon. And the reason is because carbon is in so many of these big molecules. Scientists, chemists just get tired of writing the C's out. It's like shorthand is what it is. So if you don't see the letter between two lines that come together, it is a carbon, always. So C's, H's, and O's. Now tell me about the shapes that you're looking at. And I'm saying looking at on the POGL. What do you often see? And it's not always, but it is characteristic of many of them. Does it have long chains? Okay, does it have long chains? We're looking at for those that can't find it, carbohydrates is the first box in Model 1. Okay? How would you describe that shape? Would you describe it as a long chain like a lipid?
No.
Okay, I heard a no. So tell me, and there's no right or wrong. Okay? Yeah.
They're connected.
They're connected. Ooh, we're going to come to that in just a minute. This is where I like to have fun playing, okay? So before they're connected, though, well, when you say connected, I think I might have been thinking about something different. When you say they're connected, what do you mean by that?
I mean, like it's closed off.
It's closed off. How many of you guys see that? Instead of a line, it's kind of closed off like a ring, isn't it? That's characteristic. Okay, not all of them, but often we call that ring shaped. So if I say ring shaped, does that make sense? It could be hexagon, it could be pentagon, but it's closed off like you were saying. Okay. That is characteristic, the CH's and O's and the fact that they're ring shaped. So if you see something ring shaped, closed off like that, and you don't know what kind of molecule it is, 9.5 times out of 10, it's going to be a carbohydrate, okay? And once you know what kind of molecule it is, then you can figure out what its job is and how it's going to act in your body. And that's good because you can then identify, like, maybe what you need to eat, what vitamins you need to take, what medicines you need to take to kind of help offset things. Okay, hold on one moment. I'm going to let you guys write for a second. So, I heard monosaccharide earlier. What does the prefix mono mean? 1. That is a prefix I need you guys to know. Mono equals 1. 1 is the loneliest number. Okay, mono equals 1. Okay, so let's do this. These are some side examples. Saccharide, the other part of that word refers to it being a sugar. Carbohydrates are also known as sugars. Okay, these are known as sugars and starches. Now what I'm going to do is I'm going to write down the word glucose. How many of you have heard of the word glucose before in a class? Anyone want to elaborate on what they've heard about it? And it's okay if you don't right now. Okay, we're going to find out glucose if you're diabetic. We'll talk about glucose. You're here because you have energy thanks to glucose and photosynthesis. Okay. Glucose is a monosaccharide. Okay. Now, I'm not drawing in all the O's and the H's, but it has one ring structure. Okay. The thing with all of these here, carbohydrates, amino acids, lipids, and nucleic acids, the other two categories. The one thing about this is these are macromolecules, and they are all made with single units called a monomer. So up here or somewhere on your paper, the basic building block of biomolecules or macromolecules are named monomers. Biomolecule. Okay, and so honestly, you can think of it as like a Lego brick if you want to. Okay? So they can come together in different arrangements. That's my Lego brick. Okay? So, you're going to hear that carbohydrates have monomers. The monomer of a carbohydrate, believe it or not, is a monosaccharide. It's one sugar molecule. It's just one molecule. We're going to find out that the monomers of proteins are called amino acids. We're going to spend some time with monomers because carbohydrates, it's the easiest to see it in. Okay, so we have one here. Sugars here, and this is kind of a side note, are small. Monosaccharides or disaccharides. What does di mean? And that was a question on the POGL. Or that was actually the answer to a question on the POGL. What is the prefix di? Di means two. Yes, bi means two as well. One's Latin, one's Greek. Okay, so sugars are small. Sorry, I'm not going to go off time today. So I don't know if that, okay, I didn't know if that was a timer. Okay. So sugars mean small. It's just one molecule, or you guys saw on the back side in Model 2 that you could take two monosaccharides, put them together, and you had a disaccharide, right? Okay, so it's either one of these, or they start coming together like this. That's disaccharide. They can also, and I'm going to use a different color here. I don't think. We also said another example besides sugar is starches. So for starches, I'm going to get rid of the bonds just so to make it quicker. Ignore my terrible drawing. I'm just trying to do it quickly to show that there are definitely more than one or two now connected, aren't there? Okay, so it's still called a saccharide. The building block here is still called a saccharide. But we're not just dealing with a mono or a di. We're dealing with many. Any ideas what the prefix for many is? Multi is one. It's not one we're going to use here. This is, I don't know. I'm trying to think of other words. Okay, the word that I'm thinking of may not be appropriate. Okay, but I'm trying to think of words you may have heard. How many have heard the word polygamous? Like a polygamous, like in, I know if you're sometimes some religions have polygamous, I guess, follow polygamy. Side note, don't write this down because parents might get mad at me, but it's the only word I can think of. Oh, okay, never mind. I'll give you a better word. The one I was thinking of is when you have multiple wives, if that makes sense. Polygamy. But I thought of another word that might be appropriate. Polygon. What's a polygon? Does anyone know what someone Google the word polygon.
It's a 5-sided shape.
That's a pentagon. Because penta means 5. What is can someone Google polygon for us? And what I'm going to do is get some prefixes made up for us. A list of prefixes to help us out. Prefixes. Let me write that on my hand. What's polygon? Say it out loud, whatever Google says. That's our best friend to look up information, right? What is a polygon according to Google? And don't worry, if you're getting like tired and zoning out because you've been sitting for a while, we're going to get up and stretch in a few. What is, but I need to know what the definition of a polygon is.
It's a plane figure with at least 3 straight sides and angles and typically.
Brianna, can you read that again? What did it say?
A plane figure with at least 3 straight sides.
At least 3. So more than 2, right?
And typically 5 or more.
Or 5 or more, right? So basically 3 up to whatever number of sides. So it has more than 2, it has 3 or more, it has many, and it's known as a polygon because it has many sides. So what's the prefix here in polygon that means 3 or more? In other words, many. The word polygon, what's the prefix? Pre means first. Poly. Poly means many. Okay? So when you start combining lots of these monosaccharides, these monomers of carbohydrates, you end up forming what's known as a polysaccharide, aka starch. Okay, we're going to talk about functions in a minute. How many of you have heard of the word starch before? Okay, those are sugars and starches is a nice little group. I might just focus on these two for today, actually. These two groups. Okay, so let's go back up to that monomer. Remember I said the building block of any of these 4 categories is called a monomer. Mono meaning one, mer meaning block. So what do you think a macromolecule with many of these connected building blocks is called? Polymer. How many of you have heard the word polymer? If you go into any kind of engineering, material science, anything like that, you're going to be dealing with polymers. You'll be dealing with that. So polymer means many. So yes, monosaccharide and monomer are pretty much the same thing. Saccharide's just specific for carbohydrates. Got it? Polysaccharide is the specific form of polymer for carbohydrates. Okay. Now you're like, well, I'm so tired of chemistry. I get it, I totally get it. But the last thing I want to talk about with the chemistry and the structure here before talking about why we need to know this, what the whole big point of these molecules is how they are formed. Okay? So to do this, I am going to hit stop here. Oops. So for those that are watching the notes here, we were just outside. I'll add the video to this. We were just outside modeling dehydration synthesis. Dehydration synthesis is when water is lost, just like when we lose water, we're dehydrated. But a bigger molecule is formed. Okay, so now we have 2. So whether we're making a disaccharide or a polysaccharide, as long as we're combining them, you can call it longer or bigger molecule synthesized. So when you did your POGL in Model 2, if you were struggling understanding what you were supposed to be looking for, you should have seen that there was always plus H2O. That's because water is going to be released, okay, in a dehydration synthesis. So let's call that on the flip side, we had what to break it apart?
Water.
We had hydrolysis, right? Hydrolysis was when we added water to our connected ones, to our polymer. Okay. To break it apart. Okay, so what this is, the last two, hydrolysis and dehydration synthesis, those are the names of reactions. One's to help build bigger molecules, one's to break apart. This is what Model 2 covered. You've seen it in a kinesthetic way where you guys were modeling, and I try to just clarify it in notes so you know what the important parts are here. Questions about anything that we covered today? Because I'm going to go ahead and stop the notes in a moment. Okay, hopefully you guys are seeing that what we're trying to do is bridge that with notes, bridge what you're learning. I'm trying to tie it together and present the same information that you are already learning through book reading, through videos, through POGLs, to kind of bridge it together and give you the highlights. Got it? So you need to be interacting in order to get the most out of it.